everyone. So you had these problems to try for like last 15-17 minutes. So we'll discuss them now. Okay, also preferably please have your videos on, and instead of chat, please use your mic to speak. And yeah, so that's it. We'll start. So how many of you have tried this problem? You can raise your hands or something. Like if you just even thought about it.
Can you tell what does number of partition of mean?
Okay, can you be a little louder?
Like what does partition like? How are you partitioning it?
Okay, partition is just like writing it as a sum of some things, like 1 plus 1 is equal to 3, and 2 plus 1 is equal to 3, 3 is equal to 6. So these are just three ways to partition. So like order does not matter, is the point in which you're placing. So just the numbers which you're adding matter, that's it. So for that, we usually just put them in non-increasing or non-decreasing order, whichever you prefer. Okay? Usually it's non-decreasing. So this usually might be 1 plus 2. I'm not sure actually, but the point stands. Make sense? Okay.
Yeah, got it.
So three people said that they thought about this problem. Okay, so I'll ask you guys to explain your, tell me your ideas based on the order in which you raise your hands. But first, I'll just explain the problem to everyone. So what the problem is saying, the problem is asking you to prove that the number of partitions of n, so like 3, we divided into some parts, into distinct parts. So that can be as 1 plus 2 or just 3. So there are two different partitions. First, let's say 4, you could have a partition this as 1 plus 3 or 4. Is there any other way?
2 plus 2 for distinct parts.
Yeah, so just two ways. For 5, how can you do it? 1 plus 4, 2 plus 3. Anything else? You have 1 plus 2 plus 3, 1 plus 5. Oh, this is also 5, by the way. Let's say 2 plus 4 and so forth. Right? So with this, you can make the whole thing. So now the other is number of partitions of n into odd parts. So each part should be ordered from the criterion. So 3 can just get distributed as 3, or is 1 plus 1 plus 1. Okay, let me 1 plus 1 plus 1 and 3. 4 can get distributed as 1 plus 1 plus 1. Sorry, 1 plus 3 directly, and 1 plus 1 plus 1. Yes. 5 can get distributed as 1 plus 1 plus 1 plus 1, 1 plus 1 plus 3, and 5. 6 can get distributed as.
Hello.
Hi.
Can you give, sorry for joining late. Can you give an overview of what you discussed till now?
Does anyone want to do that?
Yes, please.
Can somebody do that? Like somebody take the initiative and okay, Pranav, go ahead. Just tell them what's been discussed till now.
So he gave 4 problems to try for 15 minutes, and he's discussing one of the problems right now. The problem is you have a number n, and then you have to prove that number of partitions of n into distinct parts equal to the number of partitions of n into odd
Okay,
parts.
got it.
All right.
We can do it with a Ferret diagram.
can you not just give conclusions like that and instead give ideas? And that is actually an invalid conclusion. So please put thought into it, what you're saying, and don't interrupt. For example, when Pranav was speaking, it was not just for you. So interrupting like that is slightly rude. Please think about the problem and take your 5 minutes, 10 minutes, and then give your idea. You don't need to immediately jump on it. Okay. Right. So, uh, Theo, do you want to present your idea?
Well, uh, I tried doing the like Ferrer diagrams to try creating like a bijection between like distinct parts and odd parts. I haven't got exactly work yet, but yeah, that's what I was doing. So like the Ferrer diagram, should I explain?
Yeah, no, you don't need to explain the diagram. I'm curious how you were trying to create the bijection though.
Well, I'm not sure what the bijection will look like, but like for the partitions of n into distinct parts, um, you can make a bijection between like that and then partitions of n. Like if you list all the like numbers in the partition, well, all the distinct numbers in that partition, right? There can obviously be repeats. Then one is in that partition, and then like some like consecutive like one to some number are all the distinct numbers in the partition. Like it doesn't skip, I guess.
Okay, I think I got it. Yeah, that is a good idea. Good. Right. Okay, who else? Manoj, what is your idea? Or what did you try? So for others, I'll give a hint meanwhile for thinking. These numbers I've written in the form of the bijection. Like odd and like when I've written the two parts, like the corresponding place it's in the form of the bijection. Okay, Manoj, go on. Okay, he doesn't seem to. Sunana, what's your idea?
Okay, like creating a bijection is like the first idea, but I also have like generating functions. So like
Let's try to avoid generating functions. Generating functions will work, that's fine. I think like you can try it on your own for generating functions, but right now I would prefer if you can try, let's say, combinatorially.
okay.
Great. Teva? I'm not
Well,
mispronouncing the name, right?
yeah. Well, that's not like my name. It's just like when I created my Google account many years ago, I just put that as first name. But
Okay.
like, I think like you said that right with the hint, you wrote it in the ID, like you wrote in that bijection order. So I think like what's going on is that you're taking the even numbers and like splitting them into like a bunch of ones. Like on the left, there's even numbers. On the right, you're splitting them into a bunch of ones.
But here
So
I
I think
split
that's
six.
like,
Here I split six as 3 and 3, right?
yeah. But I think like, I don't know, something similar to that. Not
Yeah, that's,
exactly sure.
yeah, that's good. Okay.
Like
I'll
you
go
see the
one step
two
forward
is,
and write it for 7 as well then.
I had one thing to ask you.
Yeah.
Like 6 can also be mapped to this 1 plus 1 plus 1 thing. And 2 plus 4 can also map to 3 plus 3.
Yeah. I'm just like the bijection I have in mind. I've written according to that. Maybe a some different bijection.
I think I got the bijection. Can you tell?
Just a second. Okay, Pranav, go on.
So you break, if n is even, you break n into n by 2 plus n by 2. And if n by 2 is even, you break both of these into n by 4, n by 4. And you continue till you get odds. And if
So
the
you're saying, let's say if I have a into 2 to the b, then I make this into a 2 to the b copies of a. Yes, where a is
Yes.
odd.
Yeah.
A is odd. Okay. So this is let's say a map. What is the like? How do you show this is a bijection?
Like since the numbers are distinct, so when they break down into odd numbers, they will also be like somewhat distant only.
What?
Groups. I'm not able to put it in words, but like they're distinct numbers. So if you take 4, it will be broken into 1 plus 1 plus 1 plus 1 always. So you can group those 4 ones.
But how
And
do I know how many to group them into?
okay,
One, yeah.
Well, like if you look at the number of ones, right, you can look at like binary representation, like in the 1 plus 2 plus 4 corresponding to that's 1 plus 1 plus 1, right? 7 ones. So you look at the number of ones, that's 7, and then binary, that's like 1 plus 2 plus 4,
Yes,
right? So there's the unique binary representation. So you can go backwards.
exactly. That is perfect. So what he's saying is how this will work is. So on this side, we can break it onto this side, right? Just take any a into 2 to the b and split into 2 to the b copies of a. So how do we do the reverse? Now you have say n copies of a. So you want to make it into a into 2 to the I1 plus a into 2 to the I2, such that all these are distinct, right? As well. A into 2 to the IK, let's say. But you also want to make sure that these 2 into IK are distinct, because otherwise that will break our idea that it should be into distinct parts. So now if you just want to make this equal NA, what do you do? This is just the by 2 into I1 plus 2 into I2, 2 into IK is equal to N is what you want. And there's a unique way of doing this. If I1 less than I2, which is the binary representation. Yes?
can you repeat? How did you do this identity?
So we want to break N into A, right? N copies of A as A into 2 to the something, A into 2 to the something, A into 2 to the something, right?
How
Because
is this equal to 2 to the power something coming?
that's how we broke on the left hand side to the right hand side, right? We broke A into 2 to the something into copies of A. So
Yeah.
how would we want to build back is A into copies of into 2 to something, right?
Yeah, but like the number on left are distinct only, so there will be only one such A. Like
There's not one such A. Like there, like you just said there are 5 A's, right?
yeah,
So how is there one such A? What do you mean?
oh okay, I was confusing.
Like there are n copies of A that you can say for some n. I don't know how much n is. These are just odd numbers. A is an odd number. That's all you know. So all I'm asking is n into A should be, we should be able to divide it into some copies of 2 to the power, A into 2 to the I1 plus A into 2 to the I2 into 2 to the I2. For example, here I had 7 copies of 1. So I divided as 1 plus 2 plus 4. I had 1 plus 3 plus 3. So I took the copies of 1, which is just 1. Now I took the copies of 3 together and make that 6. Here I have 1 plus 1 plus 5, so I can make the 2 copies of 1 into 2 and 5. Here I have 3, and then I have 4 copies of 1. So 4, 7. Let me try it for show it for a larger number. Let's say I have 13 as 1 plus 1 plus 1 plus 3. How much is this? 6. Let's say 3 plus 3 plus 5. How would I want to change this? First, I look at the ones. There are 3 ones. So that becomes 1 plus 2. Okay? 1 plus 2 into 1. Does that make sense? You have 2 copies of 3, so that becomes 3 into 2. And you have 1 copy of 5, so that becomes 5. So this becomes 1 plus 2 plus 6 plus 5. Did that make any sense whatsoever? You can see that if we break this back using a technique, this is what will come.
Yeah.
So that's exactly what you're trying to do. You have n into A. We want to break it into A into some power of 2, because that's how we were breaking down into some power of 2 as copies of A.
We can prove converse of it by this also.
What is the converse? It's an
No, if
equality.
we are given odd number of partition, and we can prove the distinct number of partition.
Yeah, but like it's equality, so it's a bijective map. Like if A equal B, then yes, B equal A. I don't get the point.
Yeah.
So like that's what we are trying to do. We are trying to show that the number of ways of doing both things is equal. So we're trying to create a bijection. That if you have this partition of this, then you can create a partition of that. And if you have a partition of that, you can create a partition of this. And it's the same way. That's exactly what you're trying to do. And we just write it out. You tried to break 1 plus 2 plus 4 as 1 plus 1 plus 1 plus 1. They just do it backwards. How do you do it backwards? There's only one way to do it backwards. There can be only one way to do it backwards. That has to be this. Does that make sense? You can take your time to digest it. Okay, let's take example. So, can anybody tell me the ways of doing 10 into odd parts? Help me, please.
10 ones and then like 7 ones and the 3.
Okay.
4.
Okay.
4 ones and 2 threes.
Okay.
1 1 and 3 threes. 5 ones and a 5. Or 2 ones, a 3 and a 5. 3 ones and a 7.
Do you
Oh,
not
2
want to
fives
do-
also. 2 fives. 3 ones and a 7. 3 plus 7.
Continue.
Is there something else?
You
Oh,
did it.
1 plus 9. 1 plus 9.
Good. Well done. The thing I especially liked is you did it systematically. Good. Okay. So this is the ways of doing it. So now how do we create the other way? So Nana, can you help me create the bijection?
Okay, so first thing we have is 1. Rewriting. Okay,
Yeah.
so then is 1 plus 2 plus 3 plus 4.
Okay, that is okay. So let me write it down. 1 plus 2 plus.
Then
Just a second.
1, 3, 4. So then 4. That's wait, what?
Okay, so Nana, so we discussed a partition bijection, right?
Oh, okay, that way. I see. Yes, yep, we can do that. So we have 10 ones. Now we just have to represent 10 in binary, which is 2, 1 plus 2. Can anybody write 10 in binary? Okay, I'll do that.
Calm down, calm down, calm down, calm down. You can write 10 in binary. Just
Shall I?
I okay, I can do that. Yeah, it's 2 and 2. Okay, so it's 2 plus 8.
yes,
That's
good.
8.
Now,
Then we have 3 is 3, and then we have 7. 7 is 1 plus 2 plus 4. Then we have 4. 4 is 4, and 3 is that's 2, so we just write 6. Then 1, and you write this is 3, so that's like 1 plus 2. That's
One.
3 into 1 plus 3 into 6.
3
3
into
into 3
yeah,
into 1 plus 3 into 2.
good.
Then we have 5. So 5 is 1 plus 4 plus 5. Then we have 2, 3, 5. Then we have 10. Then 3 is 1 plus 2 plus 7. Then 3 plus 7, 1 plus 9.
Good. Very good. So see, like we didn't like everything automatically came. Now can you create, do you think there's another partition? Any other way of doing this? No, right? Because you could have broken it down on in the other direction as well, and it will work back perfectly. You can see 1 plus 9 if you try to break it down, this is what it is. 1 plus 2 plus 7 if you try to break it down, you'll get 1 plus 1 plus 1 plus 7, right? So Nana just built that back up, like the way we decided to break things. We decided to break 2 into 2 to the b into a into 2 to the b copies of a, right? So that is exactly what Sanana figured out a way to bring back up, build back up. Does that make sense? Good. So this was the first problem. Does everyone understand?
Yeah.
Others? I'm just getting Pranav and Sanana's
Yeah.
one. I'll say two. Others? I'll just assume that we got it done. Okay, so let's see the next problem. We'll try the first one.
Problem 1, right?
What?
Problem 1, right?
Yes.
Oh, okay. You are not labeling. I thought the
Yeah.
page number you were also labeling according to the next hour.
No, I'm just labeling in the order we are doing them.
But
I'll reorder the first page later. Okay, does everyone actually understand the problem? Because getting this to the appropriate size is tricky already. Maybe this will fit. Yay, fit. All right. Yeah, go ahead, Anurag. Go ahead, give your idea. I would prefer if you speak up. Okay, Manoj and Pranav, you both thought of this problem?
I got something just now, like maybe some way to start off. Shall I say?
Yeah, go ahead, Pranav.
So the number is maximum number of words you can pick is less than equal to 200 is what I got.
What?
So the maximum number of such words you can pick is less than equal to 200.
You can
Why?
get at least 2 per 40.
Okay, never mind. I misunderstood.
Okay. Atul, have you seen the problem before?
Seen it, I haven't done.
Okay. So can you tell what to the 40 thing you were saying?
Because if you always keep A in the last 60 places or something, in the first 40 places, you just like make B and C 0, 1 and do every binary string. Then that will work.
Yeah. So you just have 2 to the 40 ways of placing B and C in the first 40 places, and the rest 60 you fix to
Oh,
be A.
okay. I misread the problem.
Okay, I'll rephrase the problem for you a bit. Okay. Not exactly rephrasing, but somewhat. So you want to have some words. Okay, so tell me a silly thing that will always be true if you have uh, no two consonants differing. Like same place, both don't have consonants. Only one has. Yeah. So silly thing that you have.
Um, the number of each consonant should be the same.
What? Why is that true?
Oh, wait, it isn't. I got confused with it.
Yeah, no problem. So one thing I'll ask you, instead of A's, think of these as blanks. Okay. In 100 places, out of 100 places, 60 places you are putting blanks, and 40 places you are filling them. Okay.
Hello.
Yeah, Anurag, go on.
Can I speak on the idea?
I have no idea what you're saying. Can you be a bit louder?
Wait, let me switch it.
Okay, so the idea is some place you place blanks and other places you put B and C. So you have 60 blanks and 40 places you have B or C. And now in any two given words in your large set, at least one of the places where there's a B or a C, they should differ. Right? Maybe this will give you some idea.
Then there will exist one consonant such that it has a black under it.
There will exist at least one consonant.
That has black under it.
Say, you're saying if there are two words which share all consonants, is it? Like whenever they're
Yes.
both are consonants. Yes, yes. Okay. That is fine.
What do we have to tell now? So,
How many maximum different words can you create? Is that any two given words from your set of words that you create differ in at least one of the consonants?
yeah, so we got a lower bound. 2 to the power 40.
Yes, we have a lower bound as 2 to the power 8.
And so what are we doing with this blank?
I just rephrase the problem for you. So if you're given blanks, what do you really want to do? Usually when you see blanks.
Fill them.
Good. How many, what can you fill them with? What are your alphabets currently?
B or C.
Okay, how many ways to fill them? For a given word. For a given word, how many ways are there to fill them? There are 60 blanks and you have B or C. Yeah, 2 per 60, right? Just because you have 60 blanks and you have 60, you have B or C as the option. Okay. So the claim is, what is the claim? Can you tell me now if you have filled these blanks in these 2 per 60 ways?
Would like just fill everything for each blank, and then it has to all be different in 2 per 100 overall, so 2 per 40.
Yes. So what Atul just said, we filled these blanks. So there are 2 per 60 ways of filling the blanks, right? For a given word. So for your entire set, just create all possible words by filling blanks, right? If your set was else, then you will create how many words? By s into 2 to the 60. Now the interesting point is, all your words are distinct. Clearly, two words created from the same blank set, like same set of blanks, will give different words, right? Because they differ in how they're filled. Yes? But if there are two different words and you are filling blanks afterwards, so you have some word here and you have some word here, and this differs here as this is already B and this is already C. And now you are filling some blanks. Then you're filling some blanks. Obviously, you'll still get different words, right? So size of S into 2 to the 60 is less than equal to 2 to the 100 because all words you're creating are distinct and there are at most 2 to the 100 words. Just because every place could have a
Yeah.
radius. Okay, does that make sense?
Yes.
Yeah, and see, like the changes. this change is important. Just thinking of the A's as blank. Somewhat. Yeah, it's a clever problem. Does everyone understand the idea?
Yes.
Others?
Yeah.
Others, not if others understand the problem. Yeah, all right. Okay, so we'll probably discuss problem 3 and we'll not get around to problem 4, I think. So, but let's discuss problem 3 well.
The only problem I tried, you are not discussing that, which is sad.
I said which problems I'll try honestly. Like I told the order in which I'll try.
Extend the class 15 minutes so that we can discuss.
I can't. I really can't.
Right.
Okay. So for this problem, I'm just going to give everyone 5 minutes to just understand the statement, or like 7 minutes just take to understand the statement without missing anything. If you don't understand the statement even after the time, it's not an issue. I'll try to explain it then. But 5 minutes, just try it on your own. I'll continue at 8:02 or so. All right. Did you guys understand the statement?
Yes.
All right. Others? Pranav?
Yeah.
Okay. Atul,
Yeah.
you got the statement right?
Yeah. I've done this in the past.
Oh, okay. All right. So, is there anybody who did not understand the statement? Okay. So tell me this. If there is a sequence A which is equivalent to sequence B, and if the sequence B is equivalent to sequence C, then is the sequence A equivalent to sequence C?
Yes.
Why?
Follows by definition.
Huh?
Follows by definition, no, of the equivalent sequences.
Okay.
Like ith, like if element at ith index is equivalent to the jth index in A, it's equal in B also, and then it's equal in C also. So A thing corresponds to C. So they're
Good.
equal.
So this is true. So now let's try to make sense of the question. Suppose M infinite sequences with equiperiod K. Do you understand what equiperiod K is?
Yeah.
So that no two sequences are equivalent to one another, right? So let us just write all sequences down which are equivalent to like which have equiperiod K. Let us forget about not equivalent to one another for now. Okay. So let's say the sequence A1, sequence S1, S2, S2, SK are there. Okay, SK is also used. S. I don't know what's a good number. M are there. Yeah. So these are there. Now you can put them in certain groups, right? S1, S2, S3 are in Sj are in same group. If like Si is equivalent to SK, S. Okay. Like I can put all of these in the same group if they're equivalent to one another, right? So
Yes.
S1, S2, and Sn are like any n sequences.
like I'm just grouping sequences which are equivalent to one another together. I just wrote all of them down and I'm just grouping them. Right? Does it make sense?
What are these sequences made up of?
Just equiperiod K sequences.
Oh, okay.
Just
But in some cases, we will also get infinity as the answer.
what do you
Like,
mean?
for example, we if n is an even number and the period is k, two,
Let's
sorry,
say
2.
n equal to k equal to, okay.
Yes, so now we will have like now we can have 1 comma 1 comma 2 comma 2 comma 1 comma 1 comma 2 comma 2 and so on.
Yes, that is one sequence.
And you can also have 2 comma 2 and 2 comma 2 comma 2 comma 2
Okay, that is another sequence.
and all ones and then 2 comma 2 comma 1 comma 1.
Okay.
Can I tell the contradiction here?
Okay, well, there aren't
Just,
like
just,
infinite, but
just,
I got an idea now of how to
Adav,
solve it.
tell me if this and this are not equivalent.
Oh, they are.
This
But
one's
then
not.
the second and third are also equivalent.
Yes. So they both, you can't count both of them. You only count one of these.
Can I tell some idea if you don't mind?
Yeah, go ahead and now.
So like for we can get that these at most we can get out in a sequence k elements, because if it is greater than k, then there will be no cycle of k.
What? What?
Like we have to build a sequence out of at most k elements, because if it is greater than k, then we will not have a cycle of k.
Why is that?
Like if we have cycle of 3, so we can take only 3 integers, because if we take 4 integers, how will we have a cycle of 3?
I really don't know what you're saying.
Can I explain by an example?
Sure. So let me put n equal 3 and k equal 2. And now
Yes,
you're
yes.
saying any sequence that happens can only have two things, right?
Two distinct things.
Yeah. Okay. So
Okay.
let me consider this sequence. 1, 2, 3. 1, 2,
But here then
3, 2. Just 1, 2, 3 to repeating. Okay.
yes.
So this sequence
But
DSC
here
has all three things.
A1 should be equal to A3, because k is equal
No,
to 2.
no,
Yes,
no.
note that. Because
That's
we
not
have a
that's not what
period of
that's not
period
what
of
is written. That's not what is written.
we have a period of 2.
Si equal Sj if and only if Ti equal Tj.
No, I'm
So
not
when
talking about that. I'm talking about has equiperiod k statement.
I'm getting to it. Wait. So when I shift, it becomes what? 3, 2, 1, 2, 3, 2, 1, 2, right?
You are not getting what I'm saying. Can
No.
I
So yeah. Okay. Go on.
So like we have an equiperiod of 2. So we should have that A1, A2 is equal to A1 is equal to A3 and A2 is equal to A4.
No. That's what I'm telling you. That's not the case. Equiperiod 2 is not telling you that. It's saying the two sequences are equivalent. So see here, that 2 and 2 are equal, then 2 and 2 are here, like the second terms are here also equal. So if here 1 and 1 are equal, you don't need them to be the same thing, but 3 and 3 are equal. Corresponding terms should be equal if they're equal there. There's no reason A1 and A3 are equal in the statement. Do you get my point?
It is a bit blurry. Let me get it myself.
So
Okay.
read the statement once of the problem and try to think of it. Don't study. This is why I gave you 10 minutes to just understand the statement.
Can you define the first sequence 1, 2, 3, 2, 1, 2, 3 as S1?
Sure.
Yes, thank you. We have that S1 as an equiperiod of K.
I'm saying S1 has
2.
equiperiod 2. Yes.
Yeah, 2. So by the definition, if it has an equiperiod of 2, then R1, R2 is equal to like the elements can be R1.
Yeah, they're equivalent. So
Yes.
the sequences 1, 2, 3, 2 and the sequences 3, 2, 1, 2, 3, 2, 1, 2 are equivalent.
Wait, but like this equiperiod is defined upon one sequence, I guess.
So S1 is the sequence and I shifted it by 2. That's the sequence, right? 3, 2, 1, 2, 3, 2, 1, 2. If I start from here, RK, R1, R2, RK, R1, R2, and so on, and RK plus 1, R3, so R1, R2, and so on, and R3, R4, and so on, right? So this is the sequence 1, 2, 3, 2, and 3, 2, 1, 2. I don't get the issue.
Also, I think we can show that if a sequence is has equiperiod k, then if you consider the sequence like Ri where I is greater than equal to k, greater than equal to k plus 1, then that sequence is also equiperiod k, right?
What?
Like Ri sequence has equiperiod k.
So some sequence R1, R2 has equiperiod K.
Yeah. And if you consider the sequence rk plus 1,
Okay.
rk plus 2, so on, the slower sequence also has equiperiod k, right?
Yes, because you said this sequence is equivalent to this sequence. So the equiperiod is a property that does get carried over this equivalence. Because it has nothing to do with the actual values. It's just an equivalence relation.
Oh, sorry, I took that as value.
Yeah,
I did
it's
not
fine.
look at that the definition of equivalence you defined there.
Yeah, I got it. That's why I asked you to reread it 2 times. Hi, Bijen. This problem is particularly tricky in the sense that to understand the statement, because it has some notation in it in a confusing manner, you need some ability. That's why this problem is good in that respect also. It just not just tests your ability to solve the problem, but it also tests your ability to just follow complex logical statements, which is not necessarily a thing you want tested in a problem. I understand, but it's a well phrased problem, I think. Like this is also a skill that you should develop, just being able to parse something that is written maybe in a slightly notationally dense.
Can I tell now? I guess I have some idea now.
Go on.
So if we have some two sets equivalent with same equiperiod of k,
Two
two
sequences.
sequence Si and Ti equivalent.
Yes.
By the definition you defined here. So if we have some Si and Ti equivalent, we have that they have an equal period of k. So
If a sequence does not need to have an equiperiod inherently.
Actually we
if
are
they
asked
have
to
if they have an equiperiod, they have
yes
both equal equiperiods. Yes.
yes. So if they have both equal period, then if we prove that for the first k elements, the both sets are equivalent, then we will be done.
What?
Like if two sets are equivalent, then their first two, then the first k element should be also
Yes,
equivalent
but
by the definition.
is that if and only if?
Or that is.
It is if and only if. Is that what you're saying?
Yes.
Okay. So tell me this. 1 2 1 2 1 2 1 2 3 1 2. How these two are equal in the sense of the first two terms, but onwards they're not. I don't get your point. Bro. I don't get- The first two terms are equal in both. No worries, no worries.
Mr. Oliver.
Okay, so for this, I'll actually just ask you to solve me k equal 1 case. Okay, just solve for me k equal 1. That's all you're supposed to solve. Don't solve the gen code.
Um, I was trying out the case with k is equals to 2. So I got that was
Arav, your voice got cut. Arav, you're muted. If that is my mistake.
what? Oh, okay. So could I continue?
Yeah, please. Can you restart?
Okay,
No, I
so
did
I
not.
was saying that if R1 is equals to RK for some even k, then R2 will also be equal to that, and R3 will also be equal to that, and so on. So
Sorry, what?
I got so for example, like if R1 is equals to R2k to M for someone, then R1 will be also equal to, which will be equal to 2M, R2, I'm sorry, and it
If
will be equal to
R1,
R this one, and we can keep
sorry,
continuing this is
Arav,
equals
Arav,
to
Arav, Arav,
Ris are equal.
Arav, repeat. If R1 is equal to R2, is that what you're saying?
If R1 is equals to some other like even number like R4 or
Let's say
uh,
R4. Okay.
R2, okay?
If R1 is equal to
Since
R4, then
is equals to 2, so and R1 is equal to R2 also, according to like what the case that I was trying.
why is R1 equal to R2?
That is because like I was testing if like that was one of the case. The other case would be that R1 is not equal to R2, in which case that R3 will not be equal to R4, and so on. That will be the other case for k is equals to 2.
Okay, so try. Just for now, at least, just can you worry about k equal 1 instead of worrying about k equal to 2? Okay, k equal 1, n equal 1, the sequence is 1, 1, 1. Yes, you don't have any other option. So k equal 1, n is equal to 2. What are the sequences? Can you tell me? Pranav?
Yeah. 1 1 1 1 and 1 2 1 2.
That's it?
Yeah.
K is equal to 1, n is equal to 3.
I think all ones 1 2 1 2 1 2 3 1 2 3.
You sense a pattern in the sequences you're telling me?
Yeah. So there will be n sequences 1 1 2 1 2 3 1 2 3.
They are adding up like Fibonacci.
How? What?
For k is equals to 1, we get a property that there will exist a period p, meaning that r I is equals to ri plus b.
Good. Is that all though? Can you not say more?
Is it recorded or live?
I am currently speaking. I'm right here. But the video will also be put on YouTube. Yes.
Oh, sorry.
Okay. So I'll actually not go through further with this. And I'll leave you at, okay, k equal 1, the answer should be just n. And you can try to prove that these are the only sequences of mode. I think you have enough to be able to prove this. Yeah. And you can ask any doubts you have from the first two problems, and if there's an issue with the statement still.
Oh, we are not doing this problem for general K?
No. For even k equal 1, I'm not proving it for you that these are the only sequences. I think you can prove, and you should try to prove that these are the only sequences for yourself.
The proof is obvious.
Okay.
The proof is
Doubts?
obvious.
What?
The proof is obvious only, no? For k equal to 1.
No, don't say it's obvious.
Okay.
You might find it easy, but don't say it's obvious.
Does k equal, like higher values of k involve similar idea? Or it's different?
It's a clever. You have to take one or two clever steps, but it's not too far away. Again, the whole concept of these problems where I'm asking you to count or just create bijections is just you need to understand the structure sufficiently enough. If you understand the structure sufficiently enough for these sequences, you'll be able to do it. You're just able to classify what these sequences should look like. Even in the previous problems, it was about that. For example, problem 1 especially, you just need to understand how your bijection is being created and what your numbers should look like. You'll be able to do it. This one is obviously a much trickier problem than the previous ones that you have done. So don't worry about this. This is quite a good problem. All right, I'll stop screen share. Okay. Any doubts? Anything?
I'll end the recording then.
Yeah, sounds good.